Welcome back to the spring semester of chemistry. We are now, as you'll recall, adding in some math. So this will be our first video of the semester, and we're going to be talking about doing calculations with mass, stoichiometry with mass. So, first of all, we're going to talk about going from moles into mass. We started talking about this a little bit in class, and we're going to build upon the dimensional analysis technique that we used in class, as well as using the periodic table. So down here we have a diamond. Diamonds are made out of what element? Sure, carbon. The same thing that a chunk of coal mostly is. The same thing that pencil lead is. Pencil lead actually has nothing to do with lead. It was called pencil lead because they found it's actually graphite, and they found some of it in England, and it looked like lead, so they called it lead, but it's not at all like lead. Anyway, besides the point, what mass will 7.25 moles of carbon atoms have? Okay, take just a minute. I want you to write this one down. When you're solving a problem like this, it's always best to write down first what you have to start with. And what do we have to start with right here? We've got moles. And what are we looking for? Mass. So then, what we're going to need to do is set up a problem. Okay, we had 7.25 moles. 7.25 moles. And we don't want moles, right? We want it in terms of mass. So what we're going to need to do is multiply that by a fraction, which will allow us to get rid of the moles. So we want moles down here in the denominator. And what do we want up here? Well, we wanted mass, so we're going to want grams up here. Yes, I know that kilograms are the SI unit for mass, but the molecular mass is often measured in terms of grams per mole. So in 1 mole of carbon atoms, because this is carbon that we are talking about, how many grams are there? To do this, check the periodic table. Remember that number on the periodic table, the atomic mass will also be the molar mass, grams per mole. And what you should see is 12.01. Okay, so then we'll multiply these together. Remember, we can always assume that there is a 1 underneath here. And so moles will cancel, and we're left with grams, which is what we wanted. So with a bit of calculation, take just a second and do that. You should get 87.1 grams. 87.1 grams. And it's as simple as that, going from moles to mass. We'll play around with those some more in class next time. Now, atoms to mass. This is going to get a little bit more complicated because now we're going to throw in 2 steps. It's a 2-step problem. Remember, we mentioned in class that moles are very important. Moles are always going to be the stop-off point. Your first step is going to convert the number of atoms into the number of moles. Second step will convert the number of moles into the mass. You always have to stop off at the moles first. So here we have a metal called cobalt. Cobalt's an interesting sort of metal. It's used in some different sorts of applications. You can look that up if you're more interested. So what is the mass of 2.85 times 10 to the 24th atoms of cobalt? Take just a second. Write down the problem. Write down what you have to start with. Write down what you have that you're looking for. And let's proceed from there. So you're starting with atoms, and we're looking for mass. But again, we have to stop off at moles first. So let's take a look at this. Okay, let's just clear that. So let's go back and see exactly how many that was. 2.85 times 10 to the 24th. 2.85 times 10 to the 24th atoms. But we don't want atoms. We're going to want mass eventually, but not all atoms are created equal. Some atoms are more heavy than others, so we're going to need to use a fraction to take it from atoms and put it into moles, right? So we want atoms to cancel out, so we need atoms down here on the bottom. And we're going to need moles up here on the top. So, in 1 mole, how many atoms are there? If you'll remember from class, 6.02 times 10 to the 23rd times 10 to the 23rd atoms. Atoms will cancel out, and we're left with moles. Well, we don't want moles though, do we? We want mass, so now we're going to multiply it. What goes in the numerator? Well, what are we looking for? We're looking for mass, so that's going to be grams up here. And down here, well, we don't want moles, so we're going to need moles here so that it cancels out. See how this process works? Again, this is dimensional analysis. It has built-in error checking, so we know if we set it up right, everything will cancel except what we're looking for. So, in 1 mole, how many grams of cobalt are there? Well, where could you go to find that information? Periodic table. That's right. So why don't you take a look at the periodic table, plug in the mass of cobalt, and solve the problem. Just multiply across the top, divide by what's on the bottom, and you'll have the answer. We'll go over the answer to this one in class next time. I want you to solve it, but I think you can do it. It's good practice anyway. And that's atoms to mass. A nice, simple, 2-step problem. Yes, I know it's 2 steps, and I know it seems more than twice as hard as just 1 step, but atoms to mass are going to be easy compared to some of the things we're going to look at. Not that they're necessarily harder, it just requires a different way to think about it. One of the things we're going to need to talk about before we go any further is something called formula mass. We've been talking about the molar masses of elements so far, but you often don't find elements by themselves, you find them in compounds, right? So, for example, this will help us answer, what is the mass of water? Well, let's consider, what's inside of water? Water is H2O. That means you have 2 hydrogens and 1 oxygen. So the mass of water is going to be greater than either oxygen by itself or hydrogen by itself. I think you can see what I'm leading at here. You're going to have to add them together. You'll add together the masses of 2 hydrogens and 1 oxygen, giving you something around 18.2. I like to think of this technique as a molecular fruit basket. Just like a fruit basket can be considered a whole, but it's made up of a bunch of individual pieces, a compound, a molecule can be thought of as a whole, but you need to add together all the individual pieces of it. Let's try this one. The formula mass of glucose. What do you need to do this problem? Well, you're going to need to know the formula for glucose, right? Sure, you can remember it from biology. We also mentioned it the other day in class. C6H12O6. So how many things do we have here? How many carbons? 6. How many hydrogens? 12. How many oxygens? 6. So then, we just have to take the mass of carbon, which looking at the periodic table, 12.01 times 6, we've got 6 of those. The mass of a hydrogen, 1.01 times 12. And the mass of oxygen, 16, really 15.9999, but we can round to 16. Because within 4 significant figures it is 16, times 6. Find the answers to all of those, add those all up, and you will get the molar mass of glucose, the mass of 1 mole of glucose, which is going to be a combination of all these things together. And then you could go through and do problems with that too. The mass of 3 moles of water molecules. Take just a minute, pause the video, and try that. By my calculations, I get something around 54.1 grams for 3 moles of water molecules. If you're having trouble with this, please come and see me. This is just Algebra 1, but we're using it in a different way than you perhaps have used it before. One more thing and we're done. A mass-to-mass conversion. Now this to me is where chemistry starts to get really cool, because we can go from massive reactants to massive products, or mass of one reactant and find out how many grams of another reactant we need to react with it. In order to do this, you will need a balanced reaction. It's going to be a three-part problem. First of all, you have to go from the mass of the first compound to the moles of that first compound. Remember, always stopping off at moles. Second step, this is where the balanced equation comes in. You go from the moles of compound 1 to the moles of compound 2. Third step, the moles of compound 2 to the mass of compound 2. Sounds simple. We're going to practice this, and we'll practice it much more in class next time as well. So you'll get faster and faster, better and better at this. Let's take a look at a problem here. Go ahead and take a minute and write this down. So this is a reaction that we actually did before, you may remember from last semester, burning magnesium. You set a 5.00 gram piece of magnesium alight. It burns until no magnesium is left. How many grams of magnesium oxide were produced? How many grams of oxygen do you need for this reaction? I want you to take just a minute, write and balance that reaction. Okay, and here we go. You should have 2 moles of magnesium solid plus 1 mole of oxygen gas will give you 2 moles of magnesium oxide. Again, that's what these coefficients were showing us the whole time. We didn't necessarily think of it that way. We just thought of it as balancing. Okay, now to do this problem. We want to go from mass of magnesium to mass of magnesium oxide. How many grams of magnesium did we start with? That was 5. 5 grams of magnesium. Okay, but we don't want it in grams. We have to take it to moles, right? So what do we need to have on the bottom? We've got grams up here, so we got to have grams down here. And we want it in moles, so let's put moles up here. And let's keep track too that it's magnesium still. We're still talking about magnesium. So periodic table, atomic mass of magnesium, 24.3, let's go with 4 significant figures, 3,1 in 1 mole of magnesium. So that's going to take our grams of magnesium and turn it into moles of magnesium. But we don't want moles of magnesium. What are we finally interested in? Our magnesium oxide. So let's take a look here. For every 2 moles of magnesium, that's what it's telling us here, 2 moles of magnesium. How many moles of magnesium oxide are we going to have for that? Oh, also 2. Now our magnesium's canceled out, and we're left with moles of magnesium oxide. Now we're getting somewhere. Now it's just a simple mole to mass problem. All we have to do is put moles on the bottom here to get the moles to cancel out. And what's going to go on the top? Our molar mass, magnesium oxide, which by my calculations, I get 40.31. Because what did we do? Take 1 magnesium plus 1 oxygen, and that's going to be our grams of MgO. I'm sorry for my atrocious penmanship. I'm trying to use a mouse here to write. I really should get a stylus. So multiply, 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 divide, divide, and you'll get your answer. As simple as that. So by my calculations, I'm coming up with 8.29 grams. 8.29 grams of magnesium oxide. Should be about what you got. See if you can do the oxygen one. I bet you can. Remember though, we're going to take moles of magnesium and go to moles of oxygen through that before we can go into mass of oxygen. But the balanced equation is going to be different. We've got a 2 in front of the magnesium, but 1 in front of the oxygen. Just a 1. Don't forget to take that into account. We'll go over that answer in class. Good luck.